Hello everyone, my name is Xiaoping Zheng, a second-year PhD student from University of Groningen. Today, the topic of my presentation is physical activity levels of patients with chronic low back pain and central sensitization insights from a machine learning method. First of all, I want to introduce some background information. Chronic low back pain is a global prevalent chronic musculoskeletal pain. Central sensitization is often present in chronic low back pain. It is defined as increased responsiveness to nausea and non-nausea stimuli. Optimizing physical activity is often recommended in management of chronic low back pain. However, the relationship between chronic low back pain and physical activity levels is conflicting. It is often assumed that patients with chronic low back pain have less physical activity, but some study reports there are no difference. A possible explanation might be an unknown heterogeneity among samples, such as the presence of central sensitization. Therefore, this study aims to investigate physical activity patterns in patients with chronic low back pain and low and high central sensitization based on daily living accelerometer data. Patients with chronic low back pain were recruited from UMCG, and the accelerometer was warmed at the from right hip of patient, as shown in the figure, and the score of central sensitization inventory lower 40 is low CIS, and a score higher 40 is high CIS. In this method, in order to explore the different physical activity intensity level from acceleration, a hidden segment Markov model was used. It is an unsupervised machine learning method, and it can automatically cluster hidden state from acceleration. From this method, we can get duration, emission, and transition of each hidden state. Emission describes how acceleration is assigned to a hidden state. Transition probability describes how likely a hidden state transfers to other hidden state. For each group, a hidden segment Markov model was trained separately. The patient characteristics are shown in this table. 42 patients with chronic low back pain were included. This table shows the emission possibility of two groups. Here is an example of this hidden state and their observation. Based on the value of emission, we interpreted the hidden state to rest, sedentary, light activity, light locomotion, and moderate vigorous activity state. This figure shows the duration and occupation of each hidden state. We highlight sedentary state in red, and it shows that chronic low back pain minor group has lower duration of sedentary state, but occupy the same time. It means that chronic low back pain minor has more often and short rest. This table shows the transition possibility of each state. In order to make this table easier to understand, rest and sedentary state are treated as inactive state. Light activity, light locomotion, moderate vigorous state are active state. So we can find that chronic low back pain minor has higher probability to transfer to inactive state, while chronic low back pain plus group has higher probability to transfer to active state. So here I show the duration of rest, sedentary, and active states. From this figure, we can find that chronic low back pain plus group has a longer duration of active state. Chronic low back pain minor shows higher transition possibility and shorter duration of sedentary state. It may indicate that chronic low back pain minor broke tasks into smaller bits and took frequent short rest. Because resting is regarded as an avoidance strategy, the physical activity patterns of chronic low back pain minor could be related to the avoidance response pattern. Alternatively, chronic low back pain plus show higher transition possibility and duration of active state. It means chronic low back pain plus shows a prolonged period of active engagement. Therefore, the physical activity pattern of corneal pain plus might be explained by the endurance response pattern. However, avoidance and endurance response pattern might both contribute to central sensitization. Avoidance response pattern will lead to disuse-related muscle weakness and conditioning in musculoskeletal structure and central nervous system. By contrast, patients with endurance response pattern may expose the muscle to increased stress and repeat strain by overacting. We hope the result of this study might contribute to a better understanding of relationship between physical activity, central sensitization, and corneal pain, and might in the future assist in better rehabilitation interventions. Thanks for watching.